Hello everyone and welcome back to the C language lab term work series. We are covering the VTU prescribed lab term works in this video series. In this video, we will discuss about the term work number 9, that is on implementing structures. The problem statement is about implement structures to read, write, and compute average marks and the students scoring above and below the average marks. So basically, we need to create a structure which will be holding the name and marks of the student, and we need to compute average marks of the like class, and we need to compute the students scoring above average and which students scored below the average marks for class of n students. Let's let's first discuss a brief about structures. Structures in C language is nothing but it is like a data type which can hold. It is like a combination of multiple data types. We can hold int character, float, or int string character, various kinds of data type. We can pack them and hold in one structure. So structure is always declared using struct keyword followed by the name of the structure and parenthesis which will be considered as a body of the structure where we need to define the member function members of the structures like int roll number for let us assume that we are writing for a student. We have to describe what are the features or characteristic of students that can be added into structure. For structure student, we can say roll number, which will be in the form of integer, and name, which will be in the form of a string, and marks, which will be in the form of float. So comparing the array of structures, why we are discussing the array of structures is in this problem statement we might need to store the sequence of structures in the form of array so that we can compute average and do all the required things mentioned in the problem statement. So let us take a look over the array of structures. Array of structures is nothing but placing a sequence of structures in a single array. Like we all know how to store the integer array. In the similar way, instead of integer, here we will be having structure. First, let us look at a single structure. Compare this employee structure. Struct employee for employee for holding employee details. What it contains? It contains ID of integer, a string of name, and salary of the float data type. So here we are creating a array of structures of size 2. Means we are allocating memory for two structures in the sequential manner. So how we will be defining struct employee, which will be the data type of the array, and emp will be the name of the array, and size is 2. So how exactly it will be allocated in the memory is given by this flowchart diagram. So you can see for first employee of 0, employee is array of structure. In that 0 is the means zeroth index, means first structure. In first structure, 4 bytes allocated for ID of integer data type. You can look over here, size of structure is done over here. Size of is a function used to get the number of bytes allocated for a particular variable or particular data type. Size of employee, employee is the structure, sorry, employee is a array of structure. Whenever we specify employee of 2, it gives us the total array size. But whenever you specify only the employee, it gives the bytes required for a single structure. Considering single structure, integer requires 4 bytes. Name of here not 10, it should be 5 because we have taken name for size of 5, so it should be char name of 5. Character takes single byte, so name of 5 means 5 bytes will be allocated. Float takes 4 bytes, so 4 bytes for float. So total it will be 13 bytes for one structure, 13 bytes for second structure. This is how the array of structure allocation happens. This is important concept in order to understand the program which we are writing now. So sample input output, if we consider, uh, first we need to enter the number of students, then details of students like student one scored how many marks, and name of the student and all. Later we need to generate the uh, like student details. Once again we can print. The important thing is printing average marks. 79 and 94 are the scores of two students. So average will be 86.5. The student who are above this average means who have scored above 86.5 are the student who has scored 94 and the other student who has scored 79. So this is a simple program to implement using structure. Let us solve this by uh, using C programming. Hash include stdio.h header file. We are including only one header file is enough. If we need, we can include it later. We need to create a structure because the problem is based on structure. So struct student. Let us say it has one string of name, a string whose name is name because it holds the student name, and let us say it has marks in the form of integer. Structures end with the semicolon. Once we define the structures, let us try to uh, call some other functions which will do the operation on structure using main function. So we will start with the main function. Int n printf. N is for holding number of students. Enter number of students. Scanf percentage d and percent n. Student. Yes. Once we read the number of students, we need to create the array of students so that we can store en students in some variable or in some format. I will say struct student. It is the data type. Name of the array. I will say students. Students is the name of the array of the size n. En is uh, declared. Sorry, it is taken as the input from the user. First thing is to read the student details. Read student details. Uh, this function we need to implement now. We will implement it. And we need to pass two things. One is that array and how many what is the size of the uh, how many students are there. That two things we need to pass. We will implement the read student details. Void read student details. Um, what are we are getting as a parameter struct student students array means a character array. Then have the int n. N is the number of students. What we need to do is we need to just iterate over this array and means we need to execute n times. N times we need to read the name and marks of the student and we need to store it in the array. That's it. For int I equal to 0, I less than n, I plus plus. We are executing this for n times, starting with printing a message saying that enter student details. Enter details, student details for student number percentage d, which will be nothing but percentage d colon, which will be colon is nothing but just for printing styling, nothing special. uh, I I plus 1, because I will be 0 initially, so I plus 1 will give the student 1, student 2, like that kind of. Otherwise, we will be printing student 0 and all. So printf name means we are saying first enter name, uh, scanf percentage yes, not d, because it will be in the form of string. So student of I dot name. So this is how we access the structure. Students of I is the structure. For that, we are accessing the name member variable. So how we are accessing student structure name dot member name. Same way we need to do it for uh, marks. Scanf. This time it will be in the form of array, and store it as student of I dot marks. Yes, this will do the work. Double compute average. Double compute average struct. Uh, compute average I am writing because first we will write the function, then we can call this in the main function. This this function will do the reading operation successfully. The later next thing we need to do is that is computing. Computing and also we need to write about display student. Then we will look for below and above average. All this. First we will compute the average, because once we have read the marks, it is good to compute the average. Struct students. Um, I will say int n, same format as above function. Um, First have a sum, because to calculate the average, we first need to calculate the sum, then later divide that sum by n. That will be simple formula, simple way to compute the uh, um, average. Int I equal to 0, I less than n, I plus plus. Again, we are iterating over the structure, and we are adding the students of I, means ith students marks we are adding. Basically, we are adding each and every student marks into some variable. Then we are returning that sum by n. But to avoid any conflicts, let's use the typecasting operator. Uh, Let us typecast it so that the average will be returned in the perfect way. Like if it is 86.57, it it should be returned as 86.57, not as 87 or 86. For that purpose, we have used the cast operator. Another function we will complete, that is displaying. Displaying the details. Void display student details. Display student details. Struct student student uh, have a same en. This is like a function which displays the students details. So nothing much logic, just printing the student details by iterating over the arrays. Student details colon backslash n. just styling of the printing so that output will be displayed in the proper format to the user. I less than n, I plus this we are iterating so that we can go to each and every student structure and we can print their desired uh, mm, uh, desired result displaying name percentage yes, uh, percentage yes, then marks, marks, uh, percentage d, the form of integers. So what is percentages? Percentage yes is nothing but students of I, not this yes. Okay, here students of I dot name. We are printing the name of the student. Students of I dot marks. Yes, the remaining thing is we need to display which students are above and below the average. Before that, just we will complete a little bit of this main function content, that is whatever we have written, display student details, pass students, comma n, then find the average by calling the function which we wrote for finding average. It is compute average. Pass the same parameters, that is students comma n. Once you get the average, printf percentage backslash n, average is average marks is percentage with the precision of dot 2f, so that dot 2f is used so that after decimal point there will be two numbers, two digits, average. And display above average student and below average student. We will write a common function which will find out above and below average students. So I will say void, because we will just print that result in this function only. Void display above, let's have them in the same function, above, below, uh, above, below, average. Okay, any name is no problem. Struct same, struct students. Here I need to pass the n also. Along with that, I need to find above or below average. So I need to pass the double average. We have already calculated the average. We need to pass that average also. Yeah. First, we will print the students above the students who are above average. So the students who are above average. If any mistakes are happening while printing, please don't consider it. Uh, I am more focusing on implementing the structure operation. So there might be some mistakes with the printf functions, printf like display statements, pop-up statements. Uh, what I was doing, print. Yes, this is just a message. Now I need to iterate over the for loop. Sorry, iterate over the structure of arrays. Sorry, array of structures. mm, I equal to 0, I less than n, I plus plus. Yes. And if students of I dot marks means a particular student's marks is greater than the average, then he is considered as a above average student. That is printf. Just print his details, percentage yes, then percentage marks, his marks in the bracket, uh, new line character, then students of I dot name, also students of I dot marks. Yes. Uh, okay. Some mistake. Students are fine. Yes. Same thing. We need to do it for below average. The students who are below average. If it is less, yes. If it is less, then same we need to print. Means we are checking for each student whether if the student's marks is above average, we are printing it in this section saying that he is above average student. If the student's average is student's marks is less than the average marks, then we are considering him or her as a student, sorry, student with below average. So just comparing the marks and average. And you know we need to set up all this for printf to print them in proper format. And here we need to call that particular function in order to display the result. Display above below average students comma n comma average, return 0. Yes, it will do. Let us execute and see. Enter number of students. I will say 3. Student 1, I will say around 94. John 86. I will say Suresh 79. Yes, the average marks we have got as 86.33, 94, 86, 79. Yes, it comes nearly 86.33. And students who are above average is Ram, and below average are John and Suresh. You can see 86.33. So although John has scored 86, but we have made it very accurate in the program such that even because of this 0.33 marks, John has been considered as a below average by comparing it properly. We have made the proper comparison. So it is giving the expected result. Uh, Thank you for watching this video.